this video, I am going to explain how to program the 8051 IO ports with the help of the keil compiler. Before that, we'll see that what are subroutines and what are the different ports of the 8051. So subroutines. Subroutines are just a piece of code written separately from the main program, and these subroutines are used to perform the task that needs to be performed frequently. So the main use of subroutines in 8051 is to generate the delay when we are interfacing peripheral devices with the 8051. So subroutines will be called in the main program using two instructions. Those are L call and A call. So L call is nothing but it is a long call and it is a 3-byte instruction. So in this, 1 byte is a opcode and the 2 bytes are target address. And it's nothing but using L call we can call the subroutine which is present anywhere within the 64 kilobytes of memory. In case of A call, just it is a 2-byte instruction and subroutine can be called only within 2 kilobytes of ranges. So when subroutine is called, few changes occurs. So the first thing is when the subroutine is called from the main program, the processor saves the address of the instruction immediately below the call program on the stack. And then it will fetch the instruction from the new location, and after the end of the subroutine means when it executes return instruction, it will pop the address of the instruction which is stored in the stack. So next, later we will see the execution of subroutine using keil compiler. So next is the IO ports which are present in 8051. So there are 4 ports are present in 8051. Those are P0, P1, P2, P3. Among 4 ports, P0, P2 and P3 are used for multipurpose and P1 is exclusively used only for the input-output purpose. So here we need to know the few things about the IO ports of this 8051. So upon the reset of 8051, all the ports acts as input ports. But please note that when the first 0 is written to a port, it becomes an output. To reconfigure it as an input, a 1 must be sent to the port. And one more thing is, all the ports can be accessed as a byte addressable or bit addressable, and this we will see later. So now we'll see how to program the IO ports. That is how to program, like how to make use of P0, P0, P1, P2, P3 when we interface the devices. So first we will send the 55H to the port P2. So for that we will be like the instruction is usually move. First, the accumulator is initialized with 55H and that value will be moved to port P1, A. Yes, jump here and we'll write again in the first instruction. It's nothing but after like it keep on sending 55H to port P1. So in this program, port P1 acts as a output port where we are sending 55H to port P1. So let us simulate this one and see the status of port. So if you want to see the status of ports, we can go to peripheral and here we can open whichever port we require. So in this program we are making use of port P1 and we will see this. So now you can see that upon the reset, the status of P1 is FF, is nothing but the one is returned to all the pins of the port 1. So now we'll execute this and please notice that this 55H will be moved to P1. So here 55 means it is the binary value for the 55H is 01010101. So next we will see the next program, that is write a program to send the alternate values 55H and AAH continuously to port P2 with a small delay between each values. So in this we need to send 55H and AAH to port P2 with a small delay between each values. So in this program, port P2 acts as a output port. So let us simulate using compiler. So initially the A is initially is 55H and then 50. Then accumulator is load, like P2 is loaded with accumulator. Then we'll call a small delay. Next, similarly now we need to send FFH to port P2, so we'll initialize our accumulator with 0AAH. Again call delay. Yes, jump again and we'll keep on moving 55H and AH. So in this program, so now this one acts as a main program. And this delay is a subroutine. So now we need to write the subroutine, and name of the subroutine we have mentioned in the main program is delay. So about the delay we already discussed in the earlier video. So just random we will create the delay. So for that, first I'll initialize R0 with FFH. Then we'll repeat this instruction using DJNZ R0, here, and this loop goes to here. So always the end of the instruction, the subroutine should be written. So now we'll simulate this. A 10. There is an error here. Now, okay. So in this example, we'll see about subroutine. It's nothing but what happens when the subroutine is called, means what happens to the change-ups of the program counter and what happens to stack pointer, right? So now the pointer, it is showing to move a comma 55h. So let us open the peripherals. We are using port P2, so port P2. Right. So now here we'll execute step by step. So now the pointer is showing to move a comma 55h. So A will be loaded with 55h. Now you can see here A is loaded upon reset, A is having 0, 0. Now A is loaded with 55h. Now the control is there at move P2 comma A. Here also you can see in the code window, that is move P2 comma A. The program counter address is 0002, and that we can see here program counter address is 0002. So now you can see the changes in this one. The port 2 is loaded with 55h. So the next instruction is call delay. So here we are calling the subroutine. So presently the program counter address, the program counter is having address of the next instruction which is to be executed. That is call move a comma 0 AAH. So that we can see in this window. That is move the address of the move a comma 0AH is 0006. So now when we execute this one, the control is there in 000C. That is the target address of the subroutine, which you can see here. C000C. And also notice that stack pointer. So the stack point, we know that when the subroutine is called, the address of the instruction which is below the subroutine, that is move a comma 0AA, that address will be stored in the stack. So the address of this instruction is 006, and that value you can see here, this stack, that is 06, that is present in the address 09. So now it will start executing the subroutine program, and R0 is loaded with FFH, and now the DJNZ, when the DJNZ instruction will execute, R0 will be decremented step by step, that we can notice in the R0. So now R0 is loaded with FFH, now it will be FE, FB, FC, FB, FE. So this will be continued till R0 become 0. So for that we cannot wait so much time, so we'll run over. So now we'll execute now. So now we can observe in the parallel port P2, that is we are getting 55H and AAH with the small delay. So like this we can send any value to any port. Next example, we'll see that write a program for 8051 to toggle all the bits of P0, P1, P2 with a specific delay. So here there is no much difference between this program and the program which we discussed. Here we are toggling the pins of port P2, but in the present program we'll be toggling the pins of port P0, P1 and P2. So here let it move A comma hash 55H, and now we'll move A to P0 and A to P1, then P2, and then we are calling the delay. So similarly here also we'll be sending AH to P0, P1 and P2, and then we are calling the delay. So now we'll execute this. So we have port P2 here, open, port P0 all, and then similarly port P1. Okay, so now execute. So first accumulator is loaded with 55H, then P0 is loaded with 55H, P1 is loaded with 55H, and P2 is loaded with 55H. And now the instruction which is to be executed is subroutine program, and the address of the subroutine program is, you can see here, the address of the subroutine program is 0016, means our program counter should be loaded with 0016 and stack pointer should be loaded with 000A. See, program counter is loaded with 16 and our address 08 and 09 is loaded with 000A, that is address of the instruction move A comma as 000AH, which should be executed after completion of the delay. So now we can see here all the pins of port 0, port 1 and port 2 are toggling continuously with a small delay. So next example we'll see that is, in these two examples we are seeing all the ports as an output port, and the next example we'll see that how to use a port as an input port and the port as a output port. So the program here it is we need to write is, a switch is connected to pin P1.7. So write a program to check the status of switch and perform the following. If switch is equal to 0, send letter to N to port P2, and if switch is equal to 1, then send letter Y to P2. So in this, so please note that if you want to use any port as an input port, we need to send 1 to those pins. So in this example, we are seeing 7th pin of port P1 as an input. So we are setting 7th bit of port P1 by the instruction set bit P1.7. Next, if you want to check the particular bit of the port, we can use the instruction JB, that is jump if bit is equal to 1. Means if the 7th pin of port P1 is 1, then this will go to the target address, that is over. That is the instruction we are sending Y to P2. If it is not, means if the bit is 0, then this condition will fail and the instruction which is below the condition instruction will execute. So in this case, anyway, we are not connected any peripheral device. If we connected peripheral device after execution of this instruction, port P1 acts as an input port, and whatever the input status of this peripheral device, that will be read by the compiler. So now in this, see just what happens according to this program. So port P1, it is to read the switch status, and then depends upon the switch status, the character will be sent to port P2. Now we assume that if the switch status is 1, that is D7 bit of port P1 is 1, then the controller will go to the label over and it sends the ASCII value of Y to P2. See, the control comes to over and then it will send 59 to port P2. So 59 is ASCII value of Y. So now we'll assume that what happens if the switch status is 0. So right, so the switch status is 0, this condition fails, so the controller comes to the instruction move P2, n, that is nothing but sending the character n to port P2. See, the ASCII value of character n is 4e, that is sent to port P2. So like this, in this program, depends upon the switch status, we are sending letter to port P2. Thank you.